Welcome students, welcome to today's lecture. Today is the third lecture of the series Vector Integration. Now today we shall discuss about closed line integrals. In my previous two lectures you have learned about normal ordinary vector integrations and open line integrals. In this discussion we shall discuss about closed line integrals. Now what do you mean by closed? In mathematics, closed means the initial point and the final point of the curve is same. See for yourself, for this figure, if we start from O, then along path OAP we reach at P, then again along path PBO our final point is again O. So this is the notation of closed line integral over f dot dr. Now this closed circle represents the closed line integral, whereas in case of open line integral there is no such closed circle. Now remember, always this closed circle may not be present. Now see, this is also an closed line integral. Now see for yourself the path O, A, P, B, O. This is a closed path. So there is two different methods to denote the closed line integrals. One with this type of method and another is in the limit you have to write the full curve path. Now if you haven't gone through the previous lectures, links are in the description, you can go through them. And before I start my lecture, if you are new to this channel, please subscribe this channel for the upcoming videos. Okay. Now to evaluate these closed line integrals, we can divide them into two different or three different or several different open line integrals. Like for here we have only two parts. One is OAP and second is PBO. See, this OAPBO is divided into two different open line integrals, and the open line integrals will be as follows. Now what happened if this closed line integral becomes 0? If this is 0, then this vector f will represent a conservative vector. Now if a vector is a conservative vector, what will happen? Its curl will be 0. So del cross f will be a 0. Again there will be energy conservation and this vector will do no work done. So there is no work done by this vector and there is a energy conservation due to that. Now what does this closed line integral over C f dot dr represents? I just forget one thing. This C represent a curve. Okay, always C represent a curve. This is a general notation. Now what does this mean? This closed line integral means circulation of this vector, this f vector around this curve. Okay. Now let's proceed to our problems. It will help you to understand the fundamentals of closed line integrals. Our first integral is a very simple one. Now before I start the problem, please note that this circle has a anti-clockwise direction engraved in it. This means that the circle or the path C actually traversed in the positive direction. It may be written or may be not written in your exam or in your problem. Okay, and if there is no such engraved there is no such arrow mark like positive or anti-clockwise, then the general notation is like this one. This is already a positive one. If there is some clockwise direction curve, then that will be shown like this. Okay. So first we have to evaluate this f dot dr, and then we have to put these parametric forms y equal to x equal to 2 cos t, y equal to 3 cos t, where t varies from 0 to 2 pi. This is the most simplest one. Now this is our f dot dr, that is x minus 3y dx plus y minus 2x dy. We have x equal to 2 cos t, then dx equal to minus 2 sin t, y equal to 3 sin t, then dy is equal to 3 cos t dt. After putting all the values in terms of t, we have this. This is a very simple integration, and this is a simple differentiation and some multiplication, thereby some rearrangement and some trigonometric transformation, like this 18 sin square t can be converted into 9 into 2 sin square t. Now what is 2 sin square t? 1 minus cos 2t, standard formula. Or for this 12 cos square t, this is 6 into 2 cos square t, that means 6 into 1 plus cos 2t. And this one 5 sin t cos t, this is a standard integral, 0 to 2 pi sin t cos t is always 0. So there are several step jumps here, you can do them in your home. Okay, so check whether I am right or wrong. That is your homework now. Now for our next problem. Okay, before we start our next problem, we have to know some parametric forms. See, this elliptical and circular paths are the most beloved curves of the examiners, and you already know what is the parametric form of circle of radius r. There is x equal to r cos t or r cos theta, y is equal to r sin theta, theta varies from 0 to 2 pi. Normally, if any quadrant, in any particular quadrant is not given to you, okay, provided they are counterclockwise direction, that is positive direction. If the curve C is in clockwise direction, that is negative direction, then we have y equal to minus r sin t or r sin theta. Okay, likewise elliptical parametric forms are x equal to a cos t, y is equal to b sin t, whereas if this is in negative direction, we have y is equal to minus b sin t. See, these parametric forms are very much important as well as very simple for you. This is not, there is no hard and fast rule that parametric form will be given in your questions. Always parametric forms may be in hidden, like questions may come that the path C is a ellipse or the path C is a circle of radius 2 centimeter. Then you have to use these circular or elliptical, or if there is given any, that parametric form. So better to know some parametric forms before jumping into the questions. Okay, let's proceed to our second question. For the second question, we have a graph. It's a curve. Very common curve for vector integrations. A is 1 1, that is 0 0. OCA is defined by y equal to x square, and ABO is defined like x equal to y square. These are the parametric forms of these curves. What we will have to do? We have to evaluate f dot dr for two different f. First one is this, second one is this, for this closed curve. Now let's test for this one. Now for the path OCA. Now before I start doing further mathematics, always remember, follow the arrow marks. We start from O, we go to A through the path OCA, not path OBA, because of the arrow mark. See, this arrow shows me to start from here and to go from and to go to A, and this arrow mark is suggesting me to start from A then go to O. So always follow the arrow marks. Many of you mistakenly don't follow the arrow marks and ruined everything. Now for OCA, y equal to x square, so either we can convert y, all y's into x, or all x's into y. See, if I can convert x into y, then the coordinate transformation becomes a little bit complicated, like x equals to root over of y, dx become more complicated. But if I convert y into x, everything is simple. See, y equal to x square and dy equal to simple 2x dx. So I can convert y into x and vice versa. It depends upon me. Whichever is simple, I will follow that path. Now for y equal to x square, dy equal to 2x dx, now we can simply transform this f dot dr, where all the y's will be transformed into x. See, this is y equal to x square, this is y equal to x square, this dy is 2x dx, and the integral becomes 0 to 1 x plus x square plus 2x cube dx. See, y 0 to 1, this is 0 0, this is 1 1. The value, the limit of x varies from 0 to 1. Okay, and this is the answer 4/3. Now you can check for yourself the vice versa case, that is, you can transform the x into y, like x equal to root y, and then dx into something into dy, then do the same math and check for yourself whether 4/3 is the answer or not. Okay, now let's for the next path ABO. Now for the path ABO, we again have two choices. Either we can convert all the x's into y using this x equal to y square and then dx equal to 2y dy, or we can convert all the y's into x's, like y equal to root over of x, then dy equal to dx. Okay, but I choose the simple way, x equal to y square. Always use the simple way, not to be complicated. So f dot dr, where all the x's, these x's have been directly transformed into y's, and the dx has transformed into 2y dy. There are several step jumps here. Now watch out for the limit. Don't use the commonly 0 to 1, 0 to 1. Okay, this is not 0 to 1. See, our starting point is a, that is 1 1, and our final point is o, that is 0 0. So all the values, all the limits of both x and y varies from 1 to 0. Now it's a very common mistakes of you guys that for one path you use 0 to 1. This is very common and this is very easy to remember. Now for the second path, you also use 0 to 1. You often don't check what is your final point or what is your initial point. This is a very common mistake, so be very very careful. Okay, now 1 to 0, everything is converted into y, 2y cube minus y square plus y dy, and the result is minus 2/3. Now again you can check for yourself. You can also convert all the y's into x, and you can check whether minus 2/3 is the answer or not. Now for OCA and ABO, we have different values. Now what is the value of the closed line integral? This can be divided into two parts, two open line integrals, and the values are here: 4/3 minus 2/3, that is 2/3. If the examiner have added another question, comment on your answer. Then what will be the answer? F is not a conservative vector. F is rather a dissipative vector. Why not conservative? Because this is not equals to 0 and work has been done by this vector F. So energy conservation is not valid here. So F is a dissipative force. Clear? Now let's do the same with this vector. Okay. So for OCA we have y equal to x square dy equal to 2x dx, and we are converting all the y's into x's and the value we have half. And similarly for the part ABO we have the value minus half. See, this is half, this is minus half. So what is the value of the closed line integral? 0. Now comment on your answer. Very easy. Since this is 0, f is a conservative vector, so del cross f equals to 0. So this f has not done any type of work and energy is conserved here. Okay. Now you can check for yourself the del cross f value. F is given here I cap xy square plus j cap x square y, and you can easily check the value of del cross f. Okay. So that's also a homework for you now. Now let's move on to our third question. A is given. Compute the circulation of A. What is the circulation of A? Simply the closed line integral of A dot dr around the curve C in the xy plane where the center is at the origin and radius 2. Okay, it is a circle. So what will be our parametric form? X equal to 2 cos theta or 2 cos t, y is equal to 2 sin theta or 2 sin t. Since whole xy plane is given and no particular quadrant is given here, then the limit of theta or t will be 0 to 2 pi. Okay, now let's put our parametric equations like this one. Here I have used t. You can use theta or phi, anything you are free to use. Now see, we are starting from this point. T gradually grows and this vector goes from this to this to this to this and finally again here. So t is gradually increasing from 0 to pi by 2 to pi to 3 pi by 2 and again 2 pi. That's why the value or the limit of t or theta, the angle actually is 0 to 2 pi. Clear? If particular quadrant will be given to you for the sake of this first quadrant, then t from 0 to pi by 2. For second quadrant, then t will be from pi by 2 to pi. Okay. Now we are just putting all the parametric forms here. Y is equal to 2 cos 2 sin t and x equal to 2 cos t, and dx equal to minus 2 sin t dt, dy equal to 2 cos t dt, and the rest is very simple one, as like our first problem. This is a very simple problem. Okay, only the parametric form is important for you. See, there is no parametric form given. Only the description of the curve C is given. It is a circle in xy plane, center is at origin, radius 2. Okay. Now let's move on to our next problem. A square is given in the figure. Actually, in the main actual question, the figure was not drawn. I have drawn the figure for your convenience. Only the points were given 0, 0, 0, A, and A0. You have to draw the curve for yourself. Okay. Now f is given and we have to evaluate the closed line integral over C f dot dr. So this closed line integral is described as a square as a, b, c, d, a. It can be divided into 4 open line integrals like AB, BC, CD and DA. and we have to evaluate the 4 different line integrals to get the total closed line integral. Now, since this is in xy plane and f has a z component, so z component is 0 for the xy plane. So what is the value of f dot dr is simply 2xy, this is 0, dx, then x square okay. There is a printing mistake for me. This will be, there is a y missing. I am very sorry guys, this is my mistake. So x square y dy. Now for AB, we have this 0 0 to a0, there is no y. Actually y varies from 0 to 0, so value of y is 0. Then this one is 0, this one is 0, so the whole f dot dr equals to 0. So for AB, though x varies from 0 to a, we have this integral 0. Now for BC, a0 to AA, see x is not changing. What is the value of x? X equal to a, that is x equals to a, and the value of y is changes from 0 to a, so there is a change in y, so there is a change in dy, that is dy also. Since x equals to a is a constant quantity, dx equals to 0, so this first term is 0. We have only the second term where x equals to a, so f dot dr is s0 to a square y dy, that is a to the power 4 by 2. Now for CD, see AA to 0a, x y has not been changed, see a, so y equals to a, then dy equals to 0, and x changes from a to 0. Listen carefully, x changes from a to 0, not the so called 0 to 1 or 0 to a type transformation. So the limit is a to 0, this dy is equals to 0, we have 2xa dx, and the value is minus a cube. Okay, for the last part, that is dA, 0 to a to 0 0, so x has not been changed, it is 0 to 0, that is x equals to 0, hence dx equals to 0, so this thing is 0, we are left with x square y dy, but again this has a x, so whole thing is 0, f dot dr equals to 0, as well as the integral f dot dr equals to 0. So we are left with only two values for BC and for CD. So what is the closed line integral value? Simply a to the power 4 by 2 minus a cube. So again, this is not a conserved quantity, this f is not a conserved quantity. Okay, you can check it for yourself in your exercise book. Do the maths, del cross f, that will be a non-zero quantity. Okay, so it is a dissipative quantity too, and energy is not conserved here. Now let's for the next one, let C be a circle of radius a centered at the origin. So C is defined, the parametric form is x equal to a cos theta or a cos t, and y is equal to a sin theta or a sin t. Now traverse in counterclockwise direction. Okay, so our parametric form is okay. For what value of a, we have this thing equals to 1. So we have already our value 1. Only we have to determine value of a. Now this is a very interesting question. The parametric form is this one. Okay, for your convenience, this time I have used theta, and value of theta, since nothing is particular here, no coordinate has been given particularly here, so theta varies from 0 to 2 pi. Now since x equal to a cos theta, dx equal to minus a sin theta d theta, and for y a equal to a sin theta, that is dy equals to a cos theta d theta. What we'll have to do? We have to put the value of x, y, dx, dy in this equation. Okay, so x dy minus y dx equals to a cos theta x, dy is equal to this thing a cos theta d theta, and for y this is a sin theta, and for dx this is minus a sin theta d theta. Upon multiplication and the necessary steps, we have a square d theta. Then we have this thing is a square d theta. So a square is a constant quantity, 0 to 2 pi is the limit. So the integration becomes 0 to 2 pi d theta actually. That is 2 pi a square equals to 1 and a equals to 1 over root over of 2 pi. Okay. So you may find this type of questions also. It is not a fact that you have to use that classical questions. It is a little bit twisted questions. You may find this in your examinations. Okay, now let's move on to our next question. Now this is a very important question. Again, in the actual question, no curve was given, only the points were given. The curve was described as from 0 0 0 to 1 0 0, then again to the points 1 1 0, 1 1 1, 2 0 1 1, 0 0 1, and again at the last 0 0 0. See, in our previous 5 problems, all the problems were mainly 2D problems. This is the particular case, this is the 3D problem. This is a closed line integral. Okay, this is the line, the red one is the line. Okay, this is the closed line, but this is a closed line integral in 3-dimensional space. Generally these type of questions are a bit lengthy, as you know. OA, AB, BC, CD, DE, EO. So we have 1, 2, 3, 4, 5, 6. We will have to do 6 different line integrals. So it will be lengthy, but concept wise it is a very good question. What is the question? What is the value of the integral for the vector a is equal to ato around the closed loop? Okay, even like this one and this one. Now for path, okay, for path OA 0 0 0 to 1 0 0. So what is changing? This x, only this x is changing. So we have only this component, the others are 0. So dl equal to only I cap dx. Generally we know that dl equal to I cap dx plus j cap dy plus k cap dz for a 3-dimensional vector. But for this line only x is varying. So dl equal to I cap dx, and a dot dl becomes x square dx. So integration 0 to 1, that is x equals to 0 to x equals to 1, a dot dl means x square dx, and this is a very basic integral which will give 1 by 3. Now for this AB 1 0 0 to 1 1 0. So what is actually changing? This x is not changing, 1 to 1. Only y is changing from 0 to 1. So only dl's y component will be there, j cap dy, and a dot dl equals to 2yz dy. Now see, this is interesting, very interesting, because here is a z term, and what is the value of z here? 0 to 0. So value of z equals to 0. Okay, so a dot dl equals to 0, and the line integral will be a 0. See for yourself, this is 0, the whole thing becomes 0. Now remember one thing, whether you are definite about the answer, always recheck the limit. If by any chance you mistake about the limit, then number will be deducted. Now from 1 1 0 to 1 1 1, x is not changing, where x equals to 1 only. y is not changing, value of y equals to 1, z is changing from 0 to 1. So we have only dl equals to k cap dz and a dot dl equals to y square dz. What is the value of y? That is 1. So a dot dl equals to ultimately dz. We have only dz and the value is 1. Now from 1 1 1 to 0 1 1. So y and z components are not changing and their value is 1. X is changing from 1 to 0. Be very careful, the limit, lower limit will be 1, upper limit will be 0. And as well we have dl equal to I cap dx and a dot dl equal to x square dx. Only the limit is from 1 to 0. See carefully, this is 0 to 1 as it was 0 to 1, but here it is 1 to 0. Don't mistake at any limit cases, okay, then that will be a very fatal mistake. Now again this value is minus 1 by 3. Now we will go from D to E, that is 0 1 1 to 0 0 1. So z is not changing and the value is 1. X is not changing, the value is 0. Only y is changing from 1 to 0, again 1 to 0. And dl equal to j cap dy, a dot dl equal to 2yz dy. What is the value of z? Z equals to 1. So it becomes 2y dy. And I am very sorry about this printing case. I am very sorry. The integration is actually 1 to 0 2y dy, that is minus 1. You can do your mathematics here, thereby putting the value of z equals to 1 2y dy. This is y square by 2 and 2 cancels out. This is simply y square and this is minus 1. Okay, now for 0 0 1 to 0 0 0, for the last curve we have xy is not changing and their values are 0. Only z is changing from 1 to 0. So dl equal to k cap dz and a dot dl equal to y square dz, where y equals to what? Y equals to 0. So what is the value of a dot dl? 0, and as well as the integral is also 0. Okay, so we have our 1 2 3 4 5 6 integrals. Among them 2 is 0 and others are cancelling out each other, see, and the closed line integral is a 0. What does it signify? It signifies that a is again a conservative vector. You can check for yourself that whether del cross a equals to 0 or not. So for today you have several homeworks and all are same type. You have to check whether I am right or wrong, whether the given vector is conservative or not. So this is the end of our discussion today. If you like my video, then please give a thumbs up and please share your valuable comments at the comment box. Thanks for watching guys. See you soon.